students, so welcome to the next class of Science 1 Laws of Motion Chapter 1. Today we are going to discuss the uniform circular motion. I had sent you a video earlier, but to make things more clear, I am recording this and sending it to you. So as you can see here in the clock, the hands of the clock keeps on going round and round and round, and the speed also is the same, whether it's a minute hand or whether it's what you can say a second hand. It goes around in a circular path at a constant speed. So it starts from 12, then it goes back to 12 again. So that keeps on going. So such type of motion, what you can recognize is are called as uniform circular motion. So circular path of the hands of the watch is called as what? Uniform circular motion. Here in the box, as you can see, if I start from point A, it's a square. So A to B, B to C, C to D, and D to A, the object will again come back to the A. It will change the direction how many times? 4 times. If the same thing, if I do it with a pentagon, the object will go from P, Q, R, S, T. It will change the direction how many times? 5 times, and it will come back to the original point. Then if I increase the sides of this quadrilateral, like if I make it a hexagon or a heptagon, then as the size keeps on increasing, what is going to happen? The change in direction also keeps on going to increasing, but finally the object will come back to its original position, and that is called as what? Circular motion. So whether it is a box, a square, or a pentagon, hexagon, or having multiple side, as the side keeps on increasing, the change of direction keeps on increasing, and at one particular time, if I keep on increasing the side, it's going to become a circle, and that's why this is called as what? Circular motion. I hope this is very clear. In case of a bus who is traveling or a vehicle which is traveling, there are the tire keeps on showing a circular motion. So if the speed remains constant, the tire keeps on rotating at the same speed. So the tire will show a uniform circular motion if the speed of the vehicle remains constant. Similarly, if I have a thread and having a sling or a weight bound to it, and if I move it in a circular path, as you can see in diagram A, B and C, the sling keeps on rotating in a circular motion, and that will be called as what? If the speed remains same, if the object comes to the same point again and again in a per unit time, if time remains the same, then it will be called as what? Uniform circular motion. So this all examples helps us to understand what is a circular motion and what is meaning of uniform circular motion. Another example, if I want to say, when you are riding a bicycle, if your speed remains constant, then the rotation of this tire also remains constant, and in that case it is also called as what? Uniform circular motion. So from day to day life, you can connect so many examples of uniform circular motion. If I want to find out the speed when the object is in uniform circular motion, you can use a simple formula. Speed is nothing but distance upon time. Here distance is circumference of the circle upon time. So speed is equal to V. Circumference of a circle is 2 pi r upon t. So where is the r is the radius of the circle. So the formula becomes V is equal to 2 pi r upon t. That is the speed when object is in a circular motion. You can take example of what you can say, the instruments or the rides available which show circular motion. Also we are going to see, as the object shows circular motion, every time the objects rotates in a circular motion, if I try to find out the direction at each point, as you can see here, the direction keeps on changing. So this we have to keep it in mind. In a uniform circular motion, direction keeps on changing as the object is placed on it. We have some solved examples here. An athlete is running on a circular track. He runs at a distance of 400 meters in 25 seconds and return to his original position. So basically he is doing a circular motion. What is an average speed of the velocity? So distance is 400, displacement is 0 because he is coming back to the original position. Total time is 25 seconds. What we are supposed to find is average speed and average velocity. So how to find out the average speed and the average velocity? Average speed is nothing but total distance covered upon total time taken, that is 400 upon 25, that is 16 meter per second. Average velocity is total displacement upon total time taken. Total displacement, since object is coming back to the original position, the displacement is 0 upon time taken is 25. Therefore you cannot calculate this. So we can calculate the average speed in a circular path, but we cannot calculate average velocity in a circular path. Second example, An aeroplane taxis on a runway for 30 seconds with an acceleration 3.2 meter per second square before taking off. How much distance would it recover on the runway? So acceleration is given, t is given, u is given. We are supposed to find out s. We can use this formula. S is equal to ut plus half at square. So 0 into 30 plus half into 3.2 into 30 square. If you calculate this properly on your notebook, you will get it to how much? 1440 meters. So within that particular time, aeroplane has covered, what is the distance covered or displacement done with the aeroplane on the runway? It is 1440 meters. You can practice this in your notebooks. In case you have any doubts, you can ask me on a WhatsApp group. Then coming to the next, a kangaroo can jump 2.5 meters vertically. How much is the initial velocity of the kangaroo? So acceleration is the gravitational acceleration, that is 9.8 meter per second square. Since it is not given, we'll take it as acceleration due to gravity. Displacement is 2.5 meter. Initial velocity we don't know, we need to find, and final velocity when kangaroo stops jumping is nothing but 0. So v square is equal to u square plus 2a square. If you substitute everything there, you are going to get u square is equal to 49, and finally u becomes the root of 49, and root of 49 is nothing but 7 meter per second. So final velocity is nothing but 7 meter per second. As I am saying, you can go to the slide step by step, try to put the terms and try to solve it on your own, and you should be able to reach to this particular value, that the initial velocity of the object comes down to 7 meter per second. So I hope this also example is clear. Which is the formula we are using? We are using v square is equal to u square plus 2as, depending upon what values are given and what we are going to find. Fourth example, a motorboat starts from a rest and moves with a uniform acceleration if it attains a velocity of 15 meter per second in 5 minutes. So final velocity v is given 15 meter per second, time is given 5 seconds. What is the initial velocity is 0, because it's going to start from 0, and we need to find the acceleration. Very simple. A is nothing but v minus u upon t, final velocity minus initial velocity upon t, that comes down to the value which is given there. And once you get the a, that is 5 meter per second square, you can substitute in the formula. S is equal to ut plus half at square. Initial velocity is 0, so ut terms become 0, and half into 3 into 5 square becomes 75 upon 2, and finally the displacement becomes 37.5 meters. So I hope these examples are clear and you're able to understand it very clearly. Thank you so much for listening and doing it, understanding the concept. See the video 2-3 times and revise it till the time you get the numerical problems properly after revising all the formulas. And I hope you will make use of this video in learning better way. As I told, in case of any doubts, you're always welcome to ask on the WhatsApp group or on a personal chat, and I will be ready to solve your doubts. So thank you so much once again for listening it carefully, and till the time we meet next time, stay home, stay safe, take care, and enjoy these learning sessions. And please practice, keep on practicing your work daily on a daily basis.